This is question 21, and it's a question about vectors, which can be one of the most tricky topics. So what we've got here, we've got the DEF is a triangle. So we can see DEF representing the triangle. And we're told that P is the midpoint of the line FD, so the line going from F to D. Q is the midpoint of the line DE, so the line going from D to E. Midpoint of that is Q. We're also given these basis vectors here. So FD is A, so that's the vector going from F to D is A, and the vector from F to E we're given is called B. So what we've got to do is prove that the vector PQ is parallel to FE. So what that means is we're talking about this vector here going from P to Q, and we're trying to show that that is parallel to vector FE. And the way that we'll do that is we'll try and show that the direction of vector FE, which is this vector B here, is a multiple of the vector or the direction vector of PQ. So first of all, I'm going to try and find that vector PQ, and we don't know the direct route across from P to Q, but where the way vectors work is we can actually take any alternative path. So we can say that PQ is actually equal to the vector PD, so the line going from P to D, and then plus the line going from D to Q. Now, the first thing is we do know that PD is actually, since P is the midpoint of the line FD and FD is equal to A, the vector A there, we do know that PD is half of that. So we can say, first of all, PD is half of A, and we're now looking for DQ. Now we don't know that straight away, but we can just simply say that because DQ is or Q is the midpoint there, we can say that DQ is half of what DE is. So we can say it's plus half of the vector DE. So what I'm going to try and do is find the vector DE before we move on and put it back into this equation for PQ. So DE, we can actually, because we can't go straight across from D to E, we can take any alternative route. Well, we know really that DE is actually going, first of all, we could do DF and then go F to E. And what we do know is that DF is actually the opposite direction to FD. So because it's the opposite direction, we can actually say that's minus A, because FD was A, going in the opposite direction of the arrow there. We're going to go minus A in that direction. And then FE is actually B. So that's minus A plus B. So if we now replace DE in our expression for, or our equation for PQ, then what we'll get is that PQ is equal to half A plus a half, and I'm going to put this outside a bracket, minus A plus B. So then what I'm going to do is I'm going to multiply out the bracket. I'm just going to keep this one as it is first of all, obviously the half A. And then if I multiply the half into the bracket, I'm going to get that gives me half times minus A is actually going to give me not the plus, but the minus half A. And then a positive half times the positive B is going to give me plus half B. And we can see that the half A and the minus half A are going to cancel. They'll cancel each other out. And so that's going to give me just half B. Now, that is actually in the same direction because we've got that FE is equal to B and we're trying to show that PQ is parallel to FE. Well, I'm just going to summarize my information. We know that FE equals B. So in fact, I could replace B now by FE. So B there, I can put FE instead of it. So I can see that PQ is actually half of FE. And that's enough to prove that they are parallel, because really it's just saying that PQ is in the same direction as FE. It's just that it's only half its length. So we can say hence they are parallel. And that's it. That's all we need to do to prove it. So I hope that's been helpful to you. And if it has, please consider subscribing to our channel and also giving the video a thumbs up. Thanks for watching.